So let's welcome our next speaker, Anton Keks, who will tell us about Kotlin.
Okay, hello guys. For those who don't know me, I'm from Codeborn. It's a small company which makes lots of different projects. So in contrast with Planet OS or TransferWise, we are not stuck in one product or one project, so we can try out lots more different things in our different smaller projects. So that's how I used to program in Scala a little bit. So, but my experience from Scala it dates like 3 years ago. So maybe I don't remember everything very precisely. But I will be comparing Kotlin with Scala and Groovy as well. So my presentation was actually originally made for the JetConf in Minsk, where I was presenting right after the creator of Kotlin. So he was making the advertisements like, look how cool Kotlin is, and I was a little bit telling the stuff that how things really are. So as I understand, nobody of you has used Kotlin. Is it right? Raise your hands if you have used Kotlin. Okay, 2, 3 persons. And who have read or heard about Kotlin? Okay. And please raise the hands those who have who know what does the Kotlin offer, like the features of the language. Okay, some people. So I was just thinking, so how much do I need to present the language itself comparing to just telling the different kind of real-world stuff. So I will try to have a balance a little bit between the both. So yeah, I have used a disclaimer that I have used Kotlin on one commercial project, which is already finished for me, and I have used it in like 2, 3 like toy projects. So my experience also is not huge, and we started using Kotlin when it was announced that its version 1.0 is finally out. So it was like in February. That was the catalyst for us to start and try it out. The problem was that we, without knowing that, we actually started using Kotlin in the IntelliJ IDEA that was available at the time. It was like 15.04 or something, and it didn't have the latest version of Kotlin. So despite the Kotlin 1.0 was announced, we still started actually programming in Kotlin some release candidate, blah, blah. And after we upgraded accidentally to 1.0, we realized that some of our code doesn't compile anymore. So it has happened to us, but the guys actually, the creators of Kotlin, they told us that after 1.0 it will be backward compatible. So before 1.0 it was like the last time when they actually removed some of the stuff from the language that they were not sure if it's right or not. So right now it's pretty stable. Already since then, already 2 minor releases were released. So a lot of people actually have heard one of my presentations, like how can we save Java? And the thing is, like the Java really, it has lots of problems like volcanoes and overpopulation. So you can save yourself actually by choosing another island which is small without any volcanic activity in the Baltic Sea, which is called Kotlin. So if somebody doesn't know, the name of the language comes from the island in the Baltic Sea, which is near St. Petersburg, and maybe you know the city which is situated here. The name of it better, it's called Kronstadt. So the thing was that it took Kotlin 6 years to get to 1.0, quite a lot of time. So they started in 2016, and they have changed their logo several times from this kind of stuff to the more modern and cool stuff in 2016. And given the amount of time, it should be perfect language. So it's actually, the design phase was pretty long. But it's not rocket science. So if we look at rocket science, then it took 4 years for SpaceX to land the Falcon 9, actually, successfully. So that's a nice, funny comparison. But let's look at some other languages. Like C was developed during 1 year. Like C++ was developed during 4 years. I'm talking about the first 1.0. So of course they are all developing since then. So Java took 4 years, Python 3 years. Actually, I think people started using Python much earlier. So I think the first prototype was like 2 weeks or something. So JavaScript is very famous. And from that you can see that that actually it's much easier to create a dynamic language, which is powerful but dangerous, as we have learned before. So Scala 3.5 years, not like compared to Kotlin a lot less. Groovy 3.5 years. Closure 2.5 years. Go, which is now hyped language, 2.5 years. So 6 years versus these is quite a lot. Yeah, but why do I like Kotlin? So it runs on JVM. So this is a big plus for me because it means that you can use it without many modifications on any operating system, and you can use all the Java infrastructures, of course. This is the same as with Groovy. So it has binary compatibility, unlike Scala. So maybe if nothing, or if there wasn't a major revolution in Scala since version 2.10, then actually the problem is that if you compile the code with one version of Scala and try to use it with the other, all kind of bad things can happen, and this is completely unpredictable. So Scala community went away, so they compile all the libraries with all the versions of Scala, and when I was writing in Scala, the problem was that maybe there wasn't a major Scala release for quite some time now, but when there was, it was always a problem you couldn't upgrade because your favorite libraries did not compile, or you would need to compile them yourself, all of them, and it was a pain in the ass. So with Kotlin, they tell us that this won't be the case. They learn from that. They want to evolve the language also much faster than than Java is evolving, but still they understand that binary compatibility is crucial, and even source level compatibility. But for source level compatibility, they have created a very interesting and good thing. So the deprecation annotation, for example, that also exists in Kotlin, they invented a thing that to, I don't remember, either to this annotation or there is a separate annotation with which you can tell to the compiler to which method, for example, you should replace the call. So if, for example, they rename the method, you can have your IDE convert your code automatically to the new version. This is also a quite genius thing. Let's see how it will work out in the reality. So static typing, unlike Groovy. So Groovy is very nice language, but static typing is not something I give away so easily. So it's so important actually for refactoring and stuff. Of course you can in Groovy, but in Kotlin you are just doing that. So nullability. This is one of the major features of Kotlin, in my opinion, which is this is the biggest difference, I think, of Kotlin compared to Scala or Groovy or other like modern languages. So they actually, because it's being said that null was the biggest mistake in like $1 million or $1 billion mistake that was invented. So in Kotlin, there is a compile time nullability checks. So Kotlin is not the first language who does it. I think C# does it at some extent, but not exactly the same way. So there was also a very nice language that probably none of you knows. It's called Vala, which actually I think pioneered exactly the same concept that Kotlin now uses. So basically in Kotlin there is a nullable and non-nullable type, and the compiler checks very strictly. You cannot mix them easily. I will show it to you in the code shortly. So backwards compatibility is believed to be will be retained. So this is unlike if you're writing in Ruby, Python, or like any other language besides Java, I would say, you will always stuck with a big problem that upgrading the compiler will and makes your code not working or not compiling. So this is a huge problem, I think, for this kind of, for example, if you know Python, then you probably know the situation with Python 3. I think it's 4 years old, but still, in most projects in Python, still are stuck at 2.7 or 2.6. So that's a big problem. So in Kotlin, there shouldn't be this kind of stuff. So the good IDE support, I think Kotlin is only second to Java in terms of IDE support. And the reason is that it's being developed by the major IDE developer, JetBrains. So for sure, it's still a little bit behind Java, but it's now I'm looking how it's improving steadily. So now the Kotlin 1.0.2 is out, and the IDE support now has even more inspections, even more quick fixes and whatever. So it's, and they actually reuse lots of inspections from Java with Kotlin. And as Dmitry Zhemerov, who is one of the lead developers, he told me that they actually reused the same code in compiler and the IDE inspector, so that it's almost guaranteed, unlike Java and Scala, that if you see red code in IDE, it will not compile, and vice versa. So, and if the code is correct in IDE, it will be compiling as well. So with Java, even with Java 8, early there were some problems when IDE would show you red code, but it would compile or otherwise. So the runtime also is very big plus. The runtime is relatively small. I think it's the smallest from all the other JVM-based languages. It's 750 kilobytes, and it's now shrinking. So it used to be 850. Now it's in the latest release, it's 750, and it will shrink even more because most of the runtime is actually inlined methods, which are inlined by the compiler. And this is also the reason so that it's easy to guarantee the backward binary compatibility. So most of the functions in a Kotlin runtime are inlined, so that's a good thing. So it also can be compiled to JavaScript. I'm not sure if it's really a good benefit, but the theory is that you could write some business logic classes which don't depend on any like other Java APIs. You can compile them to JavaScript and run on client side, exactly the same code. So I have tried to do that. Compiling Kotlin to JavaScript, it worked. The JavaScript that you get is pretty ugly, but if you use it from the outside, from the regular JavaScript code, it looks the same as the normal JavaScript object. So that's pretty cool. Fast compilation. I put almost here because it's still slower than Java, but it's surely ahead of Scala. And actually, many of the design decisions of the language, they were based on the fact that it needs to compile fast. So for example, the biggest problem of Scala, which is implicit, Kotlin doesn't have, but it solves the same problem with extension methods. So you can still, like very easily, you can add more methods to existing classes, and you can convert them explicitly, not implicitly. And the compiler doesn't have to look and go and search everywhere if you, by any chance, have defined some implicit somewhere. So, and it's getting better again. So they have now made the incremental compilation for Android, and actually Kotlin is now big in Android because of the lightweightness, and actually if you optimize it with ProGuard, sometimes it can be even like you get only like 10 kilobytes extra to the size of the app, which is pretty cool. If you do the same with Groovy or Scala, don't try that. And potentially it will be improved faster than Java, so they are already promising a 1.1 release this autumn. So, and they only have a roadmap which features they will add, and so it's pretty cool. I think it will be now a nice and evolving community. The usage at GitHub has skyrocketed since version 1.0 was out, so it's a pretty good time to start trying it. And yeah.
Nullability. So if you call some kind of Java API which might return null, the return type in Kotlin will be nullable type, right?
I can talk about it more about it later when I show the code examples. But in Kotlin, in short, yeah, in Kotlin they have tried to treat all Java types as nullable types in Kotlin, but it ended up with very verbose code in Kotlin. So you need to do all the null checks everywhere, even if you know that this concrete library doesn't return me a null. So they have decided that they have introduced a third notion of type, like the unknown nullability type. And if you call any Java code, it's treated by a compiler as unknown, and so you can use it both the ways, as nullable and non-nullable, but only for code which is written in Java. And what Kotlin does also, which is not obvious in this actually the stuff that people usually are not talking about Kotlin, that it's in case you are using Java unknown nullability code in your like type safe nullability safe Kotlin code, then the compiler will insert runtime checks for nullability, and you will get exceptions as early as possible. Because if something is actually null, but you're not expecting it to be null. So these are some nuances that you actually, I learned it hard way, but more on that later. So the promises of Kotlin. So Java interoperability, some of the nuances is that is actually Java 6 interoperability. So it's also a good thing because you can actually use Kotlin in Android or in Google App Engine or in some environment where Java 8 is not yet supported. You can already use all the power of Kotlin actually. This is cool. But there is also a nuance that you cannot use some of the Java 8 classes or things in Kotlin. So it's, for example, it's until like a few weeks ago, it was very hard to call stream or to use the Java 8 stream API from Kotlin. I'll tell you the reason. I wanted to show some code. Let's see how it turns out. So let me open some like, no, it's not that, like Java streams. For example, so this is a Kotlin code. So I have a class called Java streams. The thing is that in Kotlin everything is public by default. So it's like hello Groovy, hello Ruby, hello most of dynamic languages. And and there are things like properties. So val should be very familiar to those coming from Scala world. So this is Kotlin has took the best things from both Scala and Groovy and many other languages. So it's a val is a immutable variable. And the thing is, like for example, we have a list here, which is list of is a helper function which actually returns us a Java util array list. So also another very good thing about Kotlin is that they haven't invented their own collections. So they're actually using the same Java collections, unlike Scala and unlike Groovy. And so if you make a collection in Kotlin, you can perfectly pass it to Java code and back, and nothing will break. This is a very good thing. So all the cool stuff that they do with collections, and they do it all, is actually achieved using the extension methods. For example, this thing returns me a Java util list, but I can like write stuff here like map and whatever. I don't need to have any stream or something like that. I have like filter, and it's all like much like simpler and shorter than in Java 8. So I don't have all this verbosity of stream and collect. But actually, if we look at if I look Control Q on this list, this actually the type of it is Kotlin list, and Kotlin list is actually an immutable list. It actually implemented behind the scenes as Java util list, but still the compiler knows that if it's Java, if Kotlin list and it's immutable, it will not compile the code that tries to add an element there or something like that. And there is another list, so if I write here mutable list, then I get a mutable list, which type is Kotlin mutable list. And this one is also Java util list in runtime, but in compile time, compiler will allow actually all the mutation methods. So this is, I asked the Kotlin's developer, how did you achieve that? Because most of the other types, they actually are compiled to JVM and they are used the same way. So if I define a class Java streams, I compile it, there will be a Java streams.class file that will be perfectly usable from Java as well. But it seems that collections are hard-coded into the compiler and treated a special way, with all the benefits that they are compatible. So the thing is, if I want to use the stream method for some reason, for in real world, of course, you never want to use that because Kotlin has all the nice collection APIs themselves. Yes. There is no parallel stream in Kotlin, and you can use Java parallel stream if you like, but I never seen it working nicely or better than the regular stream, actually. So if you have, then please give me an example. So yeah, Kotlin doesn't do too much for you. So it's a programming language. It's not a library or something. So it doesn't do all kind of like threading or synchronization, anything special. It does almost the same things as Java, but in a nicer syntax and like some more powerful language features. But what I wanted to show you is that actually, if I run this code, if you can see, I'm casting it to Java util collection, and only then, for some reason, I can call the stream method. But if I cast it to Java util list, then for some reason I cannot call the stream method. So this is a nuance in compiler, which they have fixed by adding a new Java 8 and Java 7 support library. So you can add a Java 8 support library to your project, and then you can use all the Java 8 APIs. So this is how they solved it in the meantime. So, but in reality, I never had to call the stream. And there is also one other nuance, like, or do you understand the concept of extension methods? Raise your hands. So not all. So I'll show you what that is. So for example, if I have a class, like any class, like Java util date, very simple one. So, sorry, haven't written Kotlin in a while. So you don't write new, you just call the constructor. And unlike in Scala, where you can have both for some reason, so in Kotlin there is only one without the new. So now, if I want to have a new method on this class, but I cannot do that very easily because this class is defined somewhere else. I'm not the author. So if I want to add a new method to date, so I can write that there is a function. So fun is a keyword for functions. It's like def in Groovy. And I can write a new method like date hello. And I can do like print hello here. And then I can call date hello perfectly. So this is the extension methods, and I can use it for all kinds of stuff. I can use it for explicit conversions like the Scala implicits do, and I can use it also by extending and making my API much nicer. Yes?
How big is the scope of this method?
It's visible only where you import it, basically. In the same file, or if you import this function or the file or the class that defines it. So it's not visible everywhere, only where you need it.
But if you define it inside function main, then it is accessible
Yeah.
only from
Yes.
the function.
Yes, yes. So I can define it. Kotlin also has the notion, actually, functions are first-class citizens, so I can define functions outside of classes, and like the proper way of writing the main methods in Kotlin is like that. I just define the main function, and it actually generates a Java public static final, or not final, but void main for me. So yeah, and this is very powerful thing. Or and Kotlin itself uses it a lot. So actually, most of the Kotlin runtime library is actually this kind of extension methods for collections, for threads, for like many things to make things simpler. Yes.
How does that look under the hood?
Under the hood, good question. Let's look. Actually, I wanted to use the. Let me see how they run it. Let's use Java P to see how the what does the compiler generate. So let's go to not here. It's like Kotlin. So if I compile it, yes. So I can use Java P out production Kotlin demo. This class was in Java 8. So you can see that in Java 8 there are like these kind of classes. They look like Java classes. If I have a function which is defined outside of the class, then Kotlin will create a class for JVM, which will have the same name as the source file with the KT suffix. So, for example, this Java 8 KT is the class that actually has our main method, and it also has should have this hello function. So let's look at it. Okay. Yeah. It's nice when people are following. So okay, no, it's only put the Java 8. Yeah. Java streams KT. So its signature again probably. Yeah. Let's see. Yeah. Probably it's this one. Okay. Thank you. So yeah, what does it have? It have the thing instance. So actually, there is also a notion of object like in Scala. So you can create classes or you can create objects. There is no static in Kotlin, so I can create object hello, and this will generate a class for me, a singleton for me, basically almost like in Scala. So and this is the field instance that we see here. It's for some object, and the method. I don't see the hello. Okay. Anyway, I will not now. I partly I know the answer. I wanted to show actually the different things how Kotlin compiles stuff. So for that, it will create actually a static method, and its Kotlin compiler actually it uses its own annotations. It basically it compiles the regular Java bytecode, and they actually striving to make the Java bytecode that compiler generates as similar as possible to the one that Java C generates, so that the hotspot optimizers and JIT, they would actually optimize Kotlin code as well as Java code. So they are really focusing on performance. But they also add the annotation. So all the Kotlin extra type metadata is actually put to the class file with help of annotations. So Kotlin has its own, and at runtime, if you call the Kotlin code from Java code, the compiler sees only the regular Java classes, but the Kotlin compiler would use the extra annotation, the extra info which is in the annotation. So for that, it will be defined that it extends it should be attached to Java to a class state. So the thing here is that, of course, these methods don't support polymorphism. This is but the thing is that they actually are perfect thing how to replace all these kind of utility classes which are so common in Java. So you don't need any utility classes or collections or arrays. You can attach any new functions to the same object or the class.
Speaking of add called polymorphism. Can you add a new interface to the date type, for instance?
I don't think that you can. You can only add methods or properties.
It's a function which sorts, and it assumes that it sorts things that are comparable. And you have a list of things which are not comparable, and you want to add a comparable interface. And the way you do it in Scala, obviously I'm saying Scala here, is that you add an implicit type class.
Okay, that's an interesting thing. For some reason, I believe that you can solve this problem in Kotlin, but I don't know the answer right now. I will investigate that. That's an interesting point. So, and I will show you one nuance or trouble that can come with this extension methods. So, for example, if we take the same list that we have here, there is a method for each in Kotlin. And this method exists in Kotlin, and it can be used even in Java 6. If you know that the same method was added with Java 8. And now the question is, if I call for each here in Kotlin, which one will be called? So by default, they made it safe. So if the type has the real method has a precedence. So the real method will be called, will be chosen by the compiler, not the extension method. But the problem with this method is that they want the code that is written in Kotlin and to run exactly the same way on Java 6 and Java 8. So they have created a new annotation here, which is hides member. So this is the only usage of this annotation in Kotlin runtime, and it tells the compiler that this extension method should be preferred over the real for each method which may appear in Java, or which actually exists in Java 8. So there are some nuances, and the guys told me that they're still thinking how to properly solve it globally. So they are still thinking. We'll see what is coming in Java 9 and later to see if it can break our Kotlin code or not. Hopefully not. The guys will do something. And the other thing here is that you can see that all the functions are inlined. So inline here means that that this actually in runtime this function should not exist, and it's actually the compiler will replace your call for each with the real function with the body of this function. So it means that in runtime there will be a simple for loop, like you can see there, which is very well optimized by the hotspot JVM, unlike the streams API, which is optimized a little bit less. So it will actually perform the Kotlin code. Actually, when compiled, it can perform better than Java 8 streams. And not talking about Groovy, of course, because Groovy is terribly slow if you throw anything very CPU intensive at it. So yeah. So these are some of the things. About inlining of the functions, actually, if I started talking about it, I'll show you some interesting things. Like, let's see, actually, this one. So, of course, Kotlin has lambdas, and they look their syntax of Kotlin's lambdas looks a lot like Groovy closures. And they actually can be closures as well, if needed. So they can catch the outside scope, and it can be mutable as well. So like in Groovy. So unlike Java, the stuff that I use here doesn't need to be final. So I can write val a, and I can change it here with no problems. So what is also important is that, for example, you can see this hello. Hello is actually a function that I have defined here. So hello is a function that takes some lambda as a parameter, or actually a function as a parameter. So actually Kotlin prefers to call everything functions, which I think they are. And this is a declaration of a function that takes no parameters and returns nothing. So basically unit is the same as void in Java. So yeah, this is and it actually all it does, it actually runs the function that was passed as a parameter. So the thing is now there is a syntax sugar. So normally you would call this kind of code like this, and you can do that. And but they still they introduced a special syntax for the last functional parameter of to the other function. So you can build DSLs. So actually this kind of hello looks a lot like the DSLs that are usually built in Groovy. So you can do the stuff. I'll show you in a moment. Where is my Kotlin Groovy like builders? So that's what enables actually Gradle using Kotlin. So is that you can actually have these kind of functions. You can build a DSL for you like you would do in Groovy, but with the exception that it will be completely type safe. So it will be compile time statically type checked, this DSL, unlike Groovy. So that's why it's better, because with Gradle, when you write code with using this kind of DSL, like the build script, you never know actually how to write it. You need to look the documentation. There is no normal code completion, and it's very easy to make a mistake. You can call some inexisting variable you can use, and nobody will tell you. The script will just not work. So with Kotlin, the thing is that the compiler will find the errors, and it's pretty easy to build this kind of thing. So this is also the power of Kotlin, that it's actually derived from Groovy, but with type safety. So actually here I have the same example. So you can call hello with passing a parameter of function code, and if it doesn't take any arguments, of course it's you don't need to declare here anything. So that's why it didn't take the syntax of Java 8, but it took the syntax of Groovy just to make these kind of things possible. So, and it also has the, if the function takes a parameter, it can also, if you don't define the variable, there will be also an it defined for you, like in Groovy as well. So, and the thing here is that what I wanted to show here is the return problem. So it was good that you have shown this return puzzler, which had this return. So in Kotlin there are some nuances, and I actually on the last conference I was like showing that to the Dmitry Shemerov and forced him to comment publicly at what the stuff is. But actually it's quite logical. It just feels a little bit inconsistently unless you understand what is happening. So you cannot do return here, because to avoid the mistakes. So actually if I want to write return here, it will not compile, because to avoid this kind of puzzlers that there are in Groovy and Java. So in Java actually there is the same puzzler with lambdas, that if you write return from lambda, you forget that it doesn't return from outer function, outer method. It will actually return from the lambda. So here inside of lambda you cannot write return because it's not clear what will it do. So the same here, because it's basically the same, just a little bit different syntax.
Actually, I want to comment that in Java, if you write for each, you cannot write return because this lambda is method with void.
But you can write return without any value for void methods. You cannot return a value, but you can just return from it. So the same here. The function here is also like a void function in Java terms. So, but you can define an anonymous function instead of lambda. It has a different syntax, and the thing here that from anonymous function, it generates, I think, mostly the same bytecode as the lambda here, but you can return from it. And the definition in Kotlin is that if you write return, it will return from the closest function, from a closest thing that has the fun keyword, basically. And it's pretty much makes sense. So if you really need to use return inside of lambda, you can define it as an anonymous function, and then it will work. It will work as expected, so it will return from that function, not from main. And the next thing is an inline function. So this hello inline, it's defined here as it's the same as hello, but it uses the inline keyword. So the thing is, if you think about it a little bit, then The thing is that compiler, when it shows the call of hello inline, it will substitute it with this. So the hello inline, this function will not exist in runtime. And the thing is that and that's why from inline function you can return. So, and it will actually return from, not from inline function, it will return from main. Because if you write return, then maybe in some more complex code, you would like to just return from the outer function that uses this lambda. And in Java, it's always a problem if you need that. Maybe it's a sign of bad design if you need that, but still in Java you cannot do that. And in Groovy, probably not as well. So, but in Kotlin you can, and it's actually pretty cool. I discovered this feature accidentally while writing code. I put this return accidentally without realizing that I put it inside of a lambda, and then suddenly it worked as expected. I was like, oh my god, what's happening? And then I started learning more about what it is. So, yeah. What they have? Yeah. Yeah, in Java you have code too in the bytecode, but you don't have it in the source code. You cannot write it. So, yeah, the JVM has the go-to instruction. In Java you can use a break with label, and in Kotlin too you can use that. Yeah, usually it's also a sign of bad design. So in most normal code you can use it. So there's another possibility. There's a function which I call hello inline, no inline. So it actually uses inline function, but it uses the no inline parameter. And if I write no inline parameter for this lambda, I can use this kind of feature, for example, if I need to get this parameter as a lambda. So if in this function, like there is a call of block, but the block itself doesn't exist as a variable. So it just, in bytecode, there will be exactly this code inside and nothing else. So if you compile this code, it will look like that, because it's inlined completely. But this hello no inline, it means that the function itself will be inlined, but the lambda not. So the lambda will be kept as a lambda, and then it will be called as a lambda. So in runtime it will be a lambda basically. So that's why I cannot write return here. So otherwise the function is inline. And there is also another thing which is to confuse you all even more. It's called cross-inline. And the cross-inline is another tricky modifier that actually it means, let me remember what did it mean. It's pretty hard to understand. So it's basically, it means that if you want to use, it means that this thing is inlined, but it is inlined inside of the other context which cannot return. So if I remove it, this thing, that this code doesn't compile, because this lambda, it can, inlined function, it can probably return something, but it cannot return if it's used inside of the another thing which is runnable. So it's run in another context in terms of JVM. So this thing is used pretty rarely, I would say, but I was surprised when I learned there is something like that. The developers of Kotlin, they told me that they had a hard time trying to invent a good name for this kind of construct. So this construct exists probably for compatibility with JVM, and it's not very easy to understand, and hopefully in normal code you will not use it often. So yeah, but the good thing is that the compiler will tell you if something is wrong. So it's not like Groovy. And actually, concerning my overall experience writing in Kotlin. So when I started writing in Kotlin, it was, I haven't read anything. So I knew that there is a difference between nullable and non-nullable type, like, oh, not here, sorry. Yeah, I have it here, like, whatever. So if you put the question mark to the end of the type, then it will be nullable, and only then you can assign null. So if you remove the question mark, you cannot assign null anymore, and the compiler will tell me that, for example, this doesn't make sense if it's a non-nullable type, and but you cannot do like this. So it's pretty good in most cases. But this is probably the only thing that I knew about Kotlin, and also I knew that there is a fun keyword. So I started writing in Kotlin, and I was productive right from the start. I didn't know much, and like it was said about Groovy, flat learning curves here. You cannot copy-paste Java code here and start like treating it as a Kotlin, but you really can start writing Kotlin very fast. You don't need to learn much, so you can learn step by step, and it's quite easy if you have seen Scala, if you have seen Groovy, if you have programmed in Java. So that's a good thing. And unlike Scala, so Scala is very complex language. So sorry to tell you that. So Scala is for sure very powerful language, but it's academic, and it's probably most of you know how Scala is usually and for what is criticized. And the thing is that when I was writing Scala, I had all the time, or maybe not all the time, but very often I had some points in my like code writing that the code would not compile, and I don't understand why. I look at the code and see that it should compile, but it doesn't. And I would spend like half an hour understanding why it doesn't compile. So with Kotlin, not a single time. So that's a good thing, I think, for productivity. So as Scala is developed, it was developed as a research project, and then they started pushing it to the industry. It still remains an experimental research language. And why it took the Kotlin guys, like 6 years to build the language is that they tried to eliminate most of these not understandable and strange things. So they tried really hard to make it a good practical language, which is enjoyable and easy to use. So that's a good thing about Kotlin. So I'm now quite lost my presentation, like lost track of my presentation, but it's not a bad thing. So yeah, as I told you already, there are some unexpectedly lots of differences with Java. So when I first started writing Kotlin, I thought that it's more similar than it turned out to be. So like, for example, these return types and these kind of things. So there are some surprises, but they usually, when you learn how they work, you tend to like them in most cases. There are also some gotchas, like it was said for Groovy, that not all Java code can actually execute as Groovy. There are also some gotchas with Kotlin compiler, and I have reported a couple of bugs. And for this of the bug, it's one of the Android APIs for Google Cast. You actually cannot call it directly from Kotlin. It will not compile. The thing is that in Java or in Android APIs, Google sometimes uses the same method, same name for interface, cast API. Inside of the cast class, there are two things. There is a cast API, which is an interface. There's also a cast API, which is a field which actually implements that interface. And the thing is, for Kotlin compiler, it will see the interface first, and it will not allow you to dereference anything. And for Java compiler, it's a little bit smarter. It will see if you use it as a field, it will compile it will allow you to use it as a field. If you use it as an interface, it will allow you using it as an interface. And the Kotlin developers, actually, they had some reasoning also why they did that. And but they said that maybe they will fix it in some later versions. It's easy to have a workaround. You just assign it to variable, and then you call the methods on it. So not a big problem. So streams, I already told you. And so it's basically, I would say it's a trouble for all new Java JVM languages. So when there are new features in Java appearing, all the other JVM languages, they need to catch up. The same was with Groovy. When Java 8 came out, they needed to support this stuff and whatever. Actually, does Groovy support Java Lambda syntax? It should. So it supports now both syntaxes because it tries to be compatible. Yeah, that's funny. So yeah, the good stuff here that helped me a lot is Ctrl Alt Shift K in IDEA. I'm going to show it to you because it's so cool. So let me take some random Java project. Let's take like some Java class, whatever. Like, for example, a simple this kind of class. So when I want to start converting my code to Kotlin, the Kotlin was designed that it can be used inside of the Java project. So you can have half of your classes written in Kotlin and half of your classes written in Java, and you can compile all of them at the same time. So there can be cross dependencies between Java and Kotlin classes. So the way how they achieve that is that Kotlin compiler will run first. It will understand Java syntax, and it will compile the bytecode that it will give to the Java C later, and Java C will fill in the blanks with Java classes, and then it all will work together. So they actually strived like a lot to make it happen. So now I press Ctrl-Alt-Shift-K in just a random Java project. Let's see what happens. So it tells me that there are some of the code outside of this class that need to be corrected also for it to work. I press OK, and I have a class written in Kotlin. All the getters disappeared, of course, and you can even make it better. You can see that when it converts stuff, it tries sometimes to understand is it a nullable type or not. So in this concrete class, because it doesn't have any constructor, it's a mutable class, so it's decided that this thing actually are all nullable. But in Kotlin, you can use even better syntax. So if you want to create a nice little immutable class, you can declare fields here, like this. For example, now I have defined a photo class, which has a constructor taking one parameter, which is a not nullable string, and at the same time, this ID is a field also. So I can use it here in some. Not here. I can use in some function inside here, so ID is perfectly visible from here. This is like, I think Scala does the same, right? I don't remember anymore. There is sort of a pattern matching here as well. So not quite, but the most useful use cases can be done. But this is another topic. So I wanted to show you that actually you can convert this class also to one-liner in Kotlin. So the thing that the converter does for you automatically, it's not as good as the code that you would write yourself in Kotlin, of course. But it's a good start, because in some cases it will even give you the compiling code. For like right now, if I take a class which is more complex, like take this one, which has more code. So if I convert this one, it will actually not compile. So actually in my practice, when I was compiling more code, very rarely this converter produces a compiling code, but it's usually trivial to fix. Like for example, here I used a thing that probably shouldn't be used in Java. In Java you can write like this. You can assign a variable like this and pass it further. So in Kotlin you cannot do that, because this syntax is reserved for named parameters. So we can have named parameters like in PLSQL or whatever. Maybe in Groovy, I don't remember. In Groovy also. In Groovy, yeah, in Python for sure. So this is a pretty good feature, and in Scala also, yeah. So this, as I told you, they actually took the best things from many languages. And so this is trivial to fix, and you can see also there are no checked exceptions in Kotlin. So they have fixed this problem too. So if you want to generate a JVM method that will have a checked exception and for the Java C compiler to use, then you can declare it as annotation. So checked exception in Kotlin is an annotation. So you just tell the document that this exception may be thrown, but compiler will not enforce throwing or catching. So because it kind of failed in Java. And the thing is, why does it work is because Java actually, JVM at runtime, it doesn't check checked exceptions. It's only the thing of the compiler. It's only a compiler enforcing that. So it was easier for them to generate the code without this throw stuff, and it just works. So I have only a few minutes left. So I'll see what more interesting do I have here, because the Java-like compilation speed is improved. Even the last 2 months, it's now much better. And finally, they have incremental compiling in all of the build tools. So actually, it's pretty cool right now. It also uses the idea can start a daemon, also like the fast Scala compiler has pioneered the feature. And the Gradle nowadays also. The runtime performance is really good. Is like Java, and sometimes better than Java if you depending on the language construct that you use. And runtime null checks, they may affect performance, but the guys that they used the Kotlin developers, they used JMH and this kind of stuff to actually test and verify that that the code produced is not slower than Java code in most cases. So what I mean here by runtime null checks is that what I told you, that sometimes the compiler will insert additional null checks to your code, and they will at runtime they will see if something is null and throw an exception. So this is actually I'll demonstrate it to you. There are some. Actually, I have also some puzzlers, but I don't have time to show it. So let's look. I have here. It's not that again. It's nullability. Yeah. For example, I have a class here called runtime not null. It defines a hello function which actually takes a not nullable string inside, and obviously I cannot use it like that. It will not compile. But I can still fool the compiler and say that, hey, I really want this to fail at runtime. And it will fail, of course, because Kotlin will do the null check then at runtime, and will, in this case, is even a typecast exception for Kotlin that it's a different type for Kotlin, the nullable and not nullable. You can always dereference if you do a null check, then you can convert the non-nullable to not nullable very easily. And even the compiler is quite smart. But what I wanted to show to you is if I use the same class from Java. So I use it normally, in Java it's perfectly safe. I can put the null here. The thing is that the IntelliJ idea, it's still smart, and it knows that this this thing that is expected there is not null. So actually, Kotlin compiler will put the not null annotations also to the bytecode, and Java compiler, or actually Java static analyzer, will see it and warn you that it's probably a bad idea. But if I run this code, then in this time we'll have the legal argument exception, and it will actually come from inside of the hello function. So that inside on entry point it checks that the nulls are not nullable type really. And smart casts actually is a good thing. So for example, if I define some local variable as if I define it as a nullable type, once I have checked it for null, I can dereference it without the question mark. So if for example I'm not doing the null check, this same thing will not compile. So I need to use this nice operator coming from Groovy, that safe dereference operator, or how is it called? So, but here I can use it as a not nullable type because it's inside of this null check. But of course, for some threading reasons, for example, if I have a field, actually there are no fields in Kotlin, there are only properties. But if I have a field which is nullable, if I dereference that, I still cannot write something like this, because of threading issues. So compiler doesn't know. If you use this code in multiple threads, then it still cannot guarantee that this check and somebody will not have changed it to null in the meantime. So it will still enforce the null check. And in order to fix that, you can use one of the many funny extension functions that are available in Kotlin, like let. It will actually fix the value of this variable, And after that, inside of the lambda, you are sure that it will not change. So it will convert it to not nullable. So basically, it's the same as writing this. So you write let on any type. So this is an extension function for anything. And you can, like inside of this lambda, you can write the code that need not to be null checked anymore. So this is one of the also features. Kotlin also have lots of nice things, like it emulates some of the constructs that other languages like C# it has the use. So Kotlin has a use extension function, and you can again use it on anything or on anything which is closable or auto-closable to get the same behavior as in C#, but it's not a language construct, it's a library. So the cool thing here is that lots of the thing, they tried to make the language such that you could convert many of the language features of the other languages to actually just library functions. And they would use the work the same way, so that it would be much easier to extend the language. Yes? It's actually not synchronized. It's just it reads the value of prop and then passes it as a parameter to this lambda. So if it changes in another thread here in the source, inside of lambda you still have a fixed value. So, and the same is with synchronized. Actually, synchronized is not a keyword in Kotlin. It's it's a function as well. So you can synchronize on anything like this, and it's whatever. It's just a library function. So no, not a special language construct. And the same is for many other things. So should I stop?
It's interesting to me, but do you want to continue or?
Okay, I'll try to do it quickly. So backwards compatibility, it's I already told you much of these things, but they're promising that there will be. So after 1.0 there will be no breaking changes. So about the nuances, I told you there are some of the things which are funny, like in Kotlin there is no ternary operator, and you need to write if like in Scala. So when I was writing Scala, I hated this, and I hate this in Kotlin. And the good news is that Kotlin developers, they told me that they will add it, because at first they thought that it's probably not needed because if would return the value and stuff like in Scala, all nice. But the thing is that I told them, hey, you can see as an Elvis operator. You have Elvis, but Elvis is actually a shorthand of this. So what the hell? And they told me, okay, we actually don't have a really good reason not adding this, and they promised to add it. So, yeah. And there is also stuff that, but this problem is also present in Groovy. So in Groovy you can you cannot write like this. There is a in Groovy I also searched. In Groovy there's a very long-standing feature request which is active for many years, and I don't know the reason why they are not doing that. Kotlin guys told me that probably they will do that as well. But you can write like this in Kotlin. So a double exclamation mark in Kotlin means that I don't care about the null check. So it's another way of how to say to compiler, shut up, I'm smarter than you are. So if you have something nullable, you can dereference it with this question mark, and it means that at runtime you will get exception like in Java. So basically this is the same, writing double question mark is the same as just dereferencing in Java. But you can write like this one. So where's the logic? Not this one, but this one. The same in Groovy. So with nullability in Groovy, for example, you can write like this. So because in Groovy, null is also treated as Boolean as false, like in JavaScript, like the stuff of dynamic languages. Sometimes it's cool. So in Kotlin, it's statically typed, so you cannot write like this, of course. But you can write, you can use Elvis operator actually. I didn't include it in this, so you can write like here, and you can write the question mark colon false. So it will be not too much longer, but still, when I first found it, I thought that why. And at first I written it like that, like in Java, and in the end it turned out that you can write it better. So the other thing that I don't like, and it's the same in Groovy, that if you, Kotlin also has the string template, so you can dereference stuff inside of strings without writing these ugly pluses and concatenating strings. But the thing is, if you dereference this kind of thing with something that evaluates to null, you get null string as a result. And in most cases, this is not what you want. So the same problem in Groovy and in Kotlin, and probably this is something that will not fix because this is the compatibility with string builder and stuff. So, but I would really like it to be empty string. So, why the hell do you need this null? So, yeah, I already showed it to you. With runtime nullability, there is a very big impact on the agile development. So, if you're writing test-driven development, if you're writing tests, then if you use Makito, everyone uses Makito, no? Some people, okay. So Makito, for example, is a very good thing to mock your dependencies, to make like pure unit tests. And the thing is that Makito at runtime, if you use the matchers, like you see, you write like verify something dot something is called, and with this kind of parameters, these matchers, which are, for example, any or EQ, like that you can define the criteria for verification, they all return nulls. So if you test Kotlin code, which has the which actually has the runtime null checks actually, and in Makito you try to test it by generating like a stub and putting the returning nulls there, so it will actually fail. So Makito doesn't, plain Makito doesn't work with Kotlin. So some of it works, but these matchers don't work. And there is a actually easy solution, so you can actually always write the Elvis operator and return something which is not null. But there is now a small library called Makito Kotlin, which actually adapts Makito to be much more nicer used in Kotlin, and it also fixes this problem. So some of the Java libraries need to be adapted for them to be used nicely in Kotlin, but these are quite small. And actually, Makito Kotlin lets you write a lot more nicer code than the Java version of Makito. So if you compare, for example, the argument captors and this kind of thing. So sorry for not showing the code examples because not much time. So, and there is also an option. Kotlin C also have the -6 like Java C, and there is option to avoid runtime null checks. So if you really like, you can compile your test code without the runtime null checks, and then this problem goes away, but probably you will have other problems. Yes?
Yeah, I wanted to ask how to solve the problem like that. This is very common, like in Makito, to make distinction that whether variable has a value or it doesn't. So that this non-nullable types actually doesn't allow you, like something.
But if it's a non-nullable
option in Scala.
Yeah, actually, yeah, I didn't mention the option in Scala, but I think option in Scala is much worse. Much worse way to fix the nullability problem than there is in Kotlin. So this Kotlin nullable, non-nullable types, I think they're much better, much more concise in terms of writing code comparing to Scala's optional. And optional also exists in Java 8 now. So
my question is that if you have a case that you have to distinguish whether your variable has value, like the string has a value or not.
Yeah, in this case in Kotlin you will just declare a non-nullable type. So most types, by default, all the types, all the variables are not nullable in Kotlin. So this is the good thing. And this is how actually it's you're supposed to be writing in Scala, but in Scala you can always assign a null to anything and it will just break. So in Scala there is a convention that you're supposed to be using optional if you have something which can be absent. So in Kotlin they fixed it easier, so you just declare as the type as nullable if it can really return a null, and then the compiler will force you to do a null check when you're using it. So this is how they approach. Because with optional, it's the same. You can use the special methods from optional to make the null check nicer for you. But with Kotlin, you can use Elvis operator, for example, which is much shorter and nicer syntax than using optional, in my opinion. Did I answer your question? So, yeah, and this is what I just told you. And another problem with Makito and Kotlin is that all the classes are final by default. So this is a little bit unexpected. So this is like maybe the only biggest WTF that I had when I started writing in Kotlin. So I could not mock classes, any class, you cannot mock it with Makito because simply mocking a final class is not possible. So Makito cannot extend it at runtime. So in order to mock some class in runtime, you need to declare it as open. So in Kotlin, there is a special keyword open, which is the opposite of final in Java. So all stuff is final by default, and you need to declare classes and methods that you mock. You need to define them as open in order to be able to mock them. So this is a thing that I actually didn't like much, but again, they told me that that was one of the most controversial features in Kotlin when they designed the language. And actually before the 1.0 release, they actually tried to change it. So they tried to make stuff open by default. And then they told me that all kind of unexpected stuff happened. So lots of the other language constructs and whatever, they already depended on that decision that the stuff is final by default. And they told me that so many things broke, so they decided to actually keep it that way. And they told us that probably they will introduce something in the future, like the annotation, like all open or something, that you can put to a class and it will have everything open by default. So this is the way how they may fix it in the future. So for now there is a like minor inconvenience. So when you mock something, the code will not work at first, and you need to go to the methods and declare it open, and then it will work. There is also like a problem with dependency injection. So a compiler will actually enforce you to initialize all the non-nullable stuff. So you cannot leave the nullable or not nullable properties in the class. You cannot leave them as without the value, because the compiler will not allow you to declare that. For example, if I declare anything here like var x, which is not nullable, I cannot leave it like that because it's not nullable, so it has to have a value. So it cannot be left as null like in Java by default. So I need to write something here. But what if I want to use dependency injection? Like I would like put something like that, and I don't care that it's nullable. So there is a fix for that, and there is a special keyword that you can say late init and make the compiler shut up. So it also means that you're forgetting the, or like giving away the compile time check in favor of a runtime check. So it means that if you declare something as late init, it means that it will be initialized after the constructor has been called, but you're still pretty sure that it will be initialized once you start using it. So compiler will allow it to you to have it without the value, because you tell the compiler that it will have value. Don't worry. And then when you try to use it without it getting the value, of course it will fail at runtime. But at least you've been warned in this case. And for the dependency injection, this is the correct way of doing that. So, question? If you abuse it, you will just get the null pointers in runtime. So compiler will not help you. Maybe in some case in future they will make some better new inspections in IntelliJ, so it will show you a warning or something. Like, for example, this kind of inspection, it didn't exist like a month ago, but now it tells me that, hey, this variable actually is immutable, so you can change it to val. And I think they will add even more. So they are now constantly adding more and more inspections that will keep your code better, like with Java. So, and there is also a very cool construct which have no analogs in other languages. You can define some fields using like a factory method. So there is a special keyword by, and you can declare some field like that. For example, this property, I can declare it by lazy, if I correctly remember the syntax, and here we can write like that, I think. No? Set value method on delegate, blah blah. Don't remember the syntax, but because I haven't used it actually. But the thing is that the by is a built-in language construct that allows you to declare any variables using some kind of other implementation. So there is also a feature by map, and actually you can, I think it was by map or something like that. So the point is that you can declare a class where all the fields are actually stored as values of map or something like that. So you can have a more dynamic kind of behavior, but they will, from the outside, they will look like and behave like they are actually proper fields or actually properties. So this is a very cool thing that I haven't seen anywhere else, and maybe we can, after using Kotlin more, we can invent even like cooler usages of this thing. So there are even in the official documentation there are some other ideas how you could use this thing, and the thing lazy map and something else are built-in features in Kotlin runtime. So yeah, so there are even interesting things that that compiler. This is thing that actually I don't really like, is that Groovy, for example, if it treats the Java code and Groovy code the same way. So for example, if you have a getter in Java or Groovy class, you can use it as a property in Groovy. So it doesn't matter if it's declared, this getter is declared in Groovy or in Java. So with Kotlin it's different. So if you have a getter in, I'm going to demonstrate it quickly. So not here, not here. Actually here. So yeah. We have okay, this not completely that, but anyway, if you have a getter, if you have a getter in Java, you can use it as a property in Kotlin. So it's like a compatibility, like in Groovy. But if you define a getter in Kotlin class, you cannot use it as a property from Kotlin. So this is the thing, but in Kotlin you need to have a property, proper property declaration to use it as a property. So, and I think that you want to stop me now, and I will just get to the last slide.
I wanted to start a holy war about option, but we'll do it during beer.
Okay, let's do it later. So I'm not going to. So there are actually. The thing is that I actually, I made this presentation for other audience, so I was concentrating more on the other things than I'm doing today. So the thing is that I was really, so I would say that if somebody wants me to describe Kotlin, what it is, I would say that it is better Groovy. So it's actually, I think it has everything that I miss in Groovy, miss from Groovy when I'm writing Java. It has most of the fun stuff that I miss from Scala when I write Java, and it has some extra things like nullable checks and whatever. So it actually is really a good practical language in my opinion. So, and the learning curve is pretty okay. So no problems, and it's very easy to start. You just convert a couple of classes. Actually, I was looking at the code of IntelliJ itself recently, and it's now written like that. So there are lots of classes in Kotlin. Most of the classes are still in Java, and it all works. So they are gradually converting. So it's pretty good. And the good design decisions also is that they actually, the compiler enforces you to if there is some ambiguity, the compiler would force you to take the decision in most cases. So it will not behave some unexpectedly. So actually, besides return stuff that I shown you, there are, I think, not too easy to make up some puzzlers for Kotlin. And besides some bugs also, I have found some more compiler bugs that already submitted to JetBrains. So possible to go gradually. And I think because this guy, at least on this picture, this is Andrei Preslav, which is the lead of the project. He has kind of a little bit of beard, and it's being said that every successful programming language need to have a bearded guy who actually invents it. So I think Kotlin has a chance of becoming the mainstream. So I hope that you try it, and I have some example code in GitHub. Thank you.
Questions?
Yes.
How does Kotlin behave with Spring? Can they play nice together?
I think there shouldn't be any problems. So besides of late init that you would need to use if you use some like out-to-wired properties. So in fact, despite Mockito, I didn't find any problems with any of the other frameworks. I haven't used too many of them, but I think most of them would have no trouble. Yes?
If you want to read a non-nullable value from hash map, does compiler forces you to do null pointer check? Or?
Yeah, of course. Actually, the generics are much smarter in Kotlin than they are in Java, like they are in Scala, for example. So actually, you can define as a generic type parameter also can be nullable or not nullable as the collection itself. So you can actually write a variable which is of type map, which is where the map itself is nullable and the argument inside of it is also nullable. So you can put the two question marks in two places. So, and when you read something from map, also it would fall through. Actually, yeah. In case of map, there is a good point that yes, map get always returns a nullable type. So because it doesn't guarantee that the value exists in the map. So you can, but there are some helper functions that are comparable in use cases to optional on the map class itself. So you can actually write like a method, like use it if it exists, and then start using it as if were not nullable. Or you can just put the question mark dot on it, so it will be null safe. So yeah, but my previous answer is that yeah, all collections can have nullable elements as well, and map get is always nullable. Sorry, there's a microphone behind.
Are you actually using the Codeborn? Are you actually using Kotlin at Codeborn?
Yes, as I told you in the beginning, we had one commercial project in Kotlin, and now I'm looking for opportunities to use Kotlin in other projects as well.
And were you the only one who was writing in Kotlin, or were other team members also doing that?
Can you repeat the question, please?
Were you the only one who were writing in the Kotlin?
Yes, I was the one. So no, we were two. So we always work in pairs. If you don't know about Codeborn, we can talk by the pizza. But we always work in pairs, so we had two developers, and we were both learning Kotlin from scratch. And we were productive. This is the best thing. Actually, the trick was that it wasn't, at first, it was a Japanese customer. And at first, it was because of the time difference, we couldn't tell him in advance that we have trying Kotlin in the project. And so at one morning we came to work, and there was like WTF in our Skype chat. And then we talked to him over video. Then we have managed to convince him that Kotlin is a good idea for that project. And that's how we got to use it.
Also, the second question, will you present the same stuff at the Geek Out? Because I saw the program for Geek Out, you were there.
There will be something similar. So I will now look at the program more precisely, because I've been traveling a lot recently, so I'm not I don't know what will be happening there. So I will change my presentation, but it will be based on this one.
So what about pattern matching in Kotlin?
It has the special syntax, which it has a when keyword, and you can use sort of pattern matching for it. So if you can Google that. Actually, what I tried to do with this presentation, I tried to tell you stuff that is hard to Google for. Because if you go to the Kotlin tutorial, you will find everything. So if we look at the documentation of Kotlin, and there is not a lot of documentation on Kotlin, the good thing is that you can read it all maybe in 1 or 2 evenings. So let me see when expression. So actually, when expression by default, it's something like Java switch, but a little bit better. But in more advanced cases, it becomes a little bit more like pattern matching in Scala. So you can write this kind of thing. So I think that most of the use cases actually are covered by this thing. And I want you to tell me which aren't, because I haven't used pattern matching too much in Scala.
So when you define a class with constant parameters, right, which go in brackets, can you match on these parameters inside the when clause? That's the whole point.
Okay, you mean the brackets, you mean the generics.
So, no, I mean like you define a class, then there in the brackets there are some vowels, and then there are curly brackets with the rest, right?
Yes.
So, the first part, right?
Yeah, in Kotlin, yeah. What I didn't tell you that in Kotlin there is a thing like case class in Scala, which is, for example, I can show it here. It's useful for data classes. So it's called actually data class, which is I think is a little bit better name for the thing. So it behaves mostly the same way, that it will be only class for only storing of the data, and will be mutable. It will have all the required like equals to string and whatever. And can I use data classes in when expressions? I don't know. Maybe you can. Maybe this is coming. So we will see. We need to check that more precisely. But I think that thing is pretty cool already.
Any future or async constructs in a language, do you know?
That is coming. They are wanting to actually introduce the yield, for example, like in Groovy, for example, or like JavaScript newer versions. They are also planning, they are planning to introduce one very simple language feature, don't remember its name, but that will allow you to do all kind of asynchronous processing with that. So with that simple language feature, it will, you can do actors very easily, you can do all kind of, or you can do like the coroutines like in Go, you can do these kind of things very easily in Kotlin. So they are now working on that. There is already a spec for that. I don't remember what is the name of that, but they are now working on it, and they tell us that this will be the major new feature for 1.1, which will be out this autumn. So basically, all the cool concurrency features will be implemented in Kotlin also, like in Go and in Rust, in some like more modern or newer languages, and it will require very few language features. Actually, it will be very light.
You said you kind of dislike Gradle. Will you like it when they switch to Kotlin?
If it will be faster, then yes. But my biggest concern with Gradle is it's so damn slow. So if I do the same stuff with Ant, the build usually runs like 5 times faster, even with Gradle uses the daemon. So Ant without the daemon is like 5 times faster than Gradle. I don't get that, but maybe it's the problem with Groovy or the problem with the way that Gradle is implemented. I don't know. But it's really slow, I think. Any other questions?
What about ecosystem? Like, are there already some examples of like Kotlin DSL and like where it's used? What is it maybe like?
There are actually amazingly a lot of libraries which are specifically written for Kotlin already. There are several web frameworks. There are these kind of DSL frameworks for writing of the HTML or XML, and there is Gradle is a good example. So there are quite a lot of stuff. There is a nice blog on kotlinlang.org, which actually, if they find something very cool, they usually make a post about it. And there is also a very nice testing framework for Kotlin, which is, it's not like Spock, but it's, don't remember what it's called, but it's actually more similar to Jasmine in syntax. It's spec, it's called spec. Not Spock, but spec with K also at the end. So it has a similar syntax to Jasmine in JavaScript. So if you are used to that, it actually have a nicer syntax than JUnit, I think, and can be used already. And also it can be used for Java code, for testing of Java code. Also not a problem.
Let's thank our speaker again.